So today, initial task, what does it mean to have a negative position? Well, all that means is that wherever it is you're standing, it's, I guess we could say, to the left of the zero or below zero. You're in the negative. That's it. Which, speaking of positions, let's rush through a few real quick. We did this in class as a group to throw some extra credit points, but just in case, we'll go through this real quick. I want to find 5 centimeters, that's positive. Looks like each one of these tick marks is 10, so I'll put 5 here, because that's halfway in between. Negative 10, that negative tells us to go to the left, and that's a running theme. Negatives, positives, and positive negatives, those are just ways to give direction more than anything else. Here, we're starting at 0, go to 55, so we'll go to 40. One more tick, that'd be 50, so half a tick would be 55. But then if we jump up to 2 dimensions, things can get a little bit more complicated, but not much. 5, 0. Now we've got an x component to worry about and a y component. This first example though, 5 is just half. 0 says don't go up or down, so I'm there. 10, 10, that'd be 1 and 1. 30, negative 20. So the x is the 30, that's the first number, 1, 2, 3. And then the y is negative 20, so that negative again is just direction telling us to go down, 1, 2. We could also call this 30 east, 20 south, I suppose. Flipping things around, now the negative 30 is in the x spot, so we'll go 1, 2, 3, and then up, 1, 2. There we go. And then negative 30, negative 20, 1, 2, 3, 1, 2, somewhere abouts there. Positions, you've done graphing plenty. The thing that's being added to it, the thing that's changing a little bit, is now we're getting into displacement. Displacement comes from like being displaced. You've probably done a little lab experiment in middle school maybe where you had a graduated cylinder partially filled with water, you dropped a rock or something in and the water raised. And we called that water displacement because the water was one spot, then the water level went to a new spot. If I take this textbook right there, it's sitting still. If I displace it, I just move it. It moved some amount of distance in a certain direction. So here, to keep things simple for now, 1 dimension, we had 5 here and 10 here. So there's my 2 positions, but the displacement is really what's happening in between, where I'm coming from this spot, traveling to that spot. So I will include that little arrow to make it obvious that I started here and I went that direction. Then I could ask, well, what is the displacement? Displacement is how much you moved. I went from 5 to 10, so that's a change of 5 centimeters. Down here, we're starting at 50 and going backwards all the way to 0. So my arrow is going to be pointing in the other direction. And the other direction in this case would be known as negative. So I didn't just travel 50 centimeters, I traveled 50 centimeters in the negative direction, so I could put for my displacement negative 50 centimeters. All right, got 2 more. For this one, we're starting at negative 20, going to 0. So that's going towards the positive. I started out negative, then I got back to 0. That's still a positive change. So my answer is going to end up being positive 20. But I'm going to pause there for a moment because we can get an equation out of this. Every single time I do this, I'm doing a quick little mental math check in my head. All the mental math is, though, is the equation to find displacement. I'm thinking, okay, I stopped here. That's my final position, I'll call it. And I'll write that as x subscript f. X is often used for positions. It's the variable used for positions. I'm going to tack on the subscript F, subscript being the little letter on the end for final. Then I'm subtracting my initial position. So in this case, that would be 0 minus negative 20. 0 minus negative, that does indeed give us a positive 20. So that checks out. Same thing from down here. I'm not going to bother drawing the arrow because I don't really need to in this case. I'm just looking for my displacement. I know my final position is 40 minus my initial position of negative 20. That would give me 60. So I traveled 60 centimeters in the positive direction. I went all the way from here, all the way to over here. So that's our first equation. I'm going to write it up here one more time. Anytime we get a new reliable equation, that is definitely something that I would put in my notes. This one's pretty simple, but I don't particularly enjoy memorizing equations, so I like to just have them all written down. And you'll have that luxury as well, even on exams. You'll have a note card where you can write whatever you want. And I recommend all the equations that we get. So now let's complicate things a little bit more. Jump to 2 dimensions, starting at 2020, going to 2030. Here, for our displacement, we could write it a couple different ways. For now, though, we're going to keep things relatively simple and list it as an ordered pair. And I'm going to put the units on the outside so I don't forget. For the x, I'll run through my equation, which, as a reminder, final position minus initial position. So that's 20 minus 20, that gives me 0. Then for the y component, 30 minus 20, that gives me 10. So my displacement is 0, 10, meaning I didn't travel anywhere in the x direction, but I did go up 10 centimeters. Run through a few more of these. Once again, subtract final position from initial, so that's 30 minus 20, that'd be 10. 20 minus 20, that's 0. So I just flip-flop this time. Displacement is 10, 0. This one, 3030 to 2020, that'd be 10, 10 centimeters. 10 to the right, 10 up. 2020 to 1010 for the x component. 10 minus 20 is negative 10. 10 minus 20 is negative 10. I'm going to the left 10, I'm going down 10. If I plotted that out, I have 2020, 10, 10. So to the left 10, down 10. Doing both. And now, speaking of displacement, another word that gets confused with it a lot is distance. So I need to clarify the difference there. Distance is just less information, generally speaking. If I tell you that I traveled 50 miles, you have no idea where I went. That could have been 50 miles in any direction, north, south, east, or west, or something in between. But if I give you my displacement, that's kind of like I'm giving you directions. You should be able to find me if I told you my displacement. So if I started here and traveled 50 miles east, well, if you wanted to find me, you would just start where I started, traveled 50 miles east, and then you'd find me waiting there. So the main difference is distance does not specify direction. There's no positives, no negatives, no directions, just a number and a unit, I suppose. Displacement, though, it must specify a direction. There's many different ways we can specify directions. Sometimes we just do positive, negative. Sometimes we do north, south, east, or west, or up, down, left, right, something like that. Distance doesn't have any of that, though. Displacement must have it. So keep that in mind, specifically for number 1 on this first rigor that we have. We did most of this today in class. We'll go over a little bit of it tomorrow as a group with those giant whiteboards, so you should have plenty of time to get it done in class. No homework yet.